Okay, so let's set up the partial fraction for this. This is a squared, so we're gonna have to repeat, right, a, and then repeat at the x minus 1 squared with the b. And this is degree 2, not factorable. So we have to have a degree 1, a general form of degree 1 here to use. And we're going to use cx plus d here. To combine the expression, so let's combine these two first. X minus 1 square, and you get a times by, okay, a times by x minus 1 plus b. Okay, and then finally, if you combine it all together, x minus 1 squared times by x squared plus 1. Okay, so this right here will simplify to ax minus a plus b. Okay, so ax minus a plus b, that will have to be multiplied by x squared plus 1. And the cx plus d needs to be multiplied by all of x minus 1 squared. Okay. Okay, so let's expand this. Let's multiply this with that. Okay, so we get ax cubed. Okay, and then I'm going to multiply both of these. So minus a plus b with x squared. What I'm trying to do is categorize into general form of polynomial, degree 3, and then degree 2, and then degree 1, and then a constant term. That's what I want here. Okay, so I just multiply these two. And then 1 with the ax, so that gives you the degree 1 polynomial. And then just a constant term, minus a plus b. Okay. This here, let me just expand that. Okay, so that's x squared minus 2x plus 1. Again, right, degree 3, so cx cubed. Okay, degree 2 minus 2cx squared. A degree 1. Okay, this is going to be degree 1 cx. Okay, this is degree 2, so I'll put it right beside the degree 2 here. Okay, and then minus 2dx, and then plus d. Okay, and then we need to collect, right, the x cubes together. So x cubed. So that gives you a plus c x cubed. And then the x squares. We have minus a plus b, right? Let me highlight with a different color here. And minus 2c plus d. Okay, and then the degree 1, right? So you get a plus c minus 2d x, and then the constant, minus a plus b plus d. All of that over the same base, of course. So now we do the comparison. Okay. So let me actually bring this over here down. Okay, so because this doesn't have an x cubed term, we can say a plus c must equal to 0. Okay, and all of this, minus a plus b minus 2c plus d must equal to 1. Okay, and all of this, a plus c minus 2d must equal to negative 2. And of course, lastly, minus a plus b plus d is equal to negative 1. Okay, let me create some more room here. So I can definitely say, okay, so I can see that I can set, for example, c is equal to negative a, or a is equal to negative c. Now, is there some, I can group the two of the equations to eliminate some variables really quickly. minus a plus b minus a plus b. So let's call this equation 1, equation 2, 3, and 4. In equation 2, if you just subtract with equation 4, we can quickly eliminate the a and b and the b. Okay, so minus a plus b plus d, okay, plus d is equal to -1. In fact, right, if you subtract, even d disappears. So you get minus 2c is equal to 2. So c is equal to -1, which means a will equal to, from equation 1, a will equal to +1. So it's going to fall like dominoes now. So I have a and c. So using equation 3, so it's 1 subtract 1, so it's going to be 0. So d is equal to 1. Okay, and finally, so a was equal to 1, so -1. B was equal to, we're trying to find b. C was equal to -1, and d was equal to 1. Okay, what is that? +2, right? These two cancel out. So b is equal to -1. All right, let's bring this down here. Okay, so this will be, right, from this form here. Okay, so let's write it. A was equal to 1, so 1 over x minus 1. B was equal to -1, so -1 over x minus 1 squared. C is equal to -1, so -1. Actually, it's cx plus d, so it's -1x plus d was equal to 1. Okay, create a little bit more room. Okay, so this one is easy. It's just going to be ln of absolute value of x minus 1. And that's going to be actually just the plus of 1 over x minus 1. Okay, so if you differentiate that, you get the minus of this. Okay, and okay, so this right here, let's separate further. Minus x over x squared plus 1 dx plus integral of 1 over x squared plus 1. Okay, so that we can do by substitution. We use a different color pen. Let's let x squared plus 1 equal to u. Then you get 2x dx is equal to du. So x dx is equal to half of du. So minus, we have minus dx here. Is equal to minus half of du. So this is going to equal to integral of minus half du over u. And that's just arctan, inverse tangent of x. Almost done. So that's minus half ln of u, absolute value of u was equal to x plus 1. And because x squared plus 1 is always positive, we actually don't need that absolute value. Done.